Hello, good morning, dear students. Today we are going to solve October-November 2011 1-2 paper. It's a MCQ paper. The course is Physics 5054. On your screen, we are bringing in the question number. Question number one, let me reduce the size so you can see all the options. The diagram shows a parachutist in four positions after she jumps from a high balloon. At which position does she have terminal velocity? When a body is falling at terminal velocity, its velocity becomes constant. There is no change in the velocity. The acceleration is zero, the resultant force is zero. So terminal velocity, there will be no acceleration. So C is the option for question number, sorry, C will be the option, C not accelerating. So that's the terminal velocity. C is the option. Okay, question number two is on your screen. The propeller on a boat pushes water backwards with a force of 2000 Newton. The boat moves through the water against a total resistive force of 1800 Newton. You see, the propellers are applying force on water 2000 Newton. The water will apply the same force but in opposite direction on the propeller. Is the Newton's third law of motion pair of forces. According to Newton's third law, what is the force? What is the forward force on the propeller due to the water? It will be 2000 Newton. It's a pair of Newton's third law of motion. The pair of force of Newton's third law of motion. The propeller applied force on the water, and the water will apply the force on the propeller. Propeller applied force 2000 Newton on water. The water will apply 2000 Newton force on the propeller. So C is the option. C is the option. Question number two, C is the option. Question number three is on your screen. The graph shows part of a journey made by a cyclist. It's a speed time graph given here. How far did the cyclist travel in the 7 seconds? So what we will do, it's a speed time graph and we want to find out how much distance it traveled in 7 seconds. From speed time graph, you can find the distance traveled, and the distance traveled is equals to the area under the speed time graph. So this is the speed time graph given to you. We will divide this into two portions. This first portion, if I will draw an imaginary line here, then this thing will be a rectangle. Draw another line here, then this thing will be a trapezium. Find the area of the rectangle, find the area of the trapezium, add both the areas, and that will give you the total distance traveled by the cyclist in 7 seconds. The distance, the area of this rectangle will be length into width. That will be 5 into 4, and that will be 20. And the area of the trapezium here will be 1 by 2 into height into sum of parallel sides. So height will be 5 to 7, 2. This will be the length for parallel line number 1, and its length will be 4, and this will be parallel line number 2, and its length will be 6. So it will be 1 by 2 into 2 into 4 plus 6. So 4 plus 6 will be 10, multiplied by 2 it will be 20, 20 divided by 2 it will be 10. So the area of the trapezium will be 10, area of the rectangle will be 20. Add these areas, 20 plus 10 it will be 30. For your convenience, I am done this on a paper. You can see distance is equals to the area of the rectangle plus area of the trapezium. Area of the rectangle will be length into width, and the area of the trapezium will be 1 by 2 into half into sum of parallel sides. So 4 into 5 plus 1 by 2 into 2 into 4 plus 6, and the answer, the total answer will be 30 meter. I hope that is a numerical and you have understood it. So the choice will be B. Question number 3, the choice will be B, 30 meter. This will be the choice. Okay, let's move to the next question. Question number 4 is on your screen. An engine pulls a truck at a constant speed on a level track. The link between the truck and the engine breaks. The driving force on the engine remains constant. What effect does this have on the truck and on the engine? Because when the link will break, the engine the load on the engine will reduce, but the power of the engine is still the same. So what will happen? The engine will accelerate. And when the link breaks, the forward force on the truck will disappear. So the truck will start decelerating. So truck will slow down and the engine will speed up. For question number 4, B is the choice. The truck will slow down and the engine will speed up. So B is the choice. Question number 4, B is the choice. Okay, on your screen, I hope you can see the weight of a stone is found using a Newton meter and its mass is found using a pan balance. The experiment is carried out on the Earth and on the Moon. For each meter, is its reading the same or different on the Earth and on the Moon? You see, the Newton meter's reading depends upon the weight, or it depends upon the gravitational field strength of the location, at the location, sorry. And the pan balance readings, they do not depend upon the weight, they do not depend upon the gravitational field strength, they do not depend upon the location. So when you will take the reading of the Newton meter on the Moon, the reading will be different from that of its reading on the Earth. But when you will take the reading of the pan balance on the Moon, the reading will be the same on the Moon as that was on the Earth. So for the Newton meter, it should be different, and for the pan balance, it should be the same. So for question number 5, B is the choice. Okay, on your screen we have, let me increase the size. Okay, question number 6. Question number 6 is on the screen. The diameter and the length of a thin wire, approximately 1 meter in length, are measured as accurately as possible. What are the best instruments to use? Because the length of the wire is almost 1 meter, so we can use a rule. And because the diameter of the wires is always measured with the micrometer, so for diameter use micrometer and for length use rule. So for question number 6A is the choice. For question number 6A is the choice. Question number 7 is on your screen. A quantity is quoted as having a value of 6.2 ms. The m is smaller. In what unit is it measured? You know, the smaller m stands for milli and s stands for second. So this is in milliseconds. For question number 7, D is the option, milliseconds. I hope you have understood it. Okay, on your screen we have question number 8. The efficiency of an electric generator is 65%. The energy input to the generator is 12 kilojoules. What is the useful energy output? Because the generator is only 65% efficient, so the output energy, useful output energy, will be 65% of the 12 kilojoules. So we will calculate it mathematically and we will get the answer. I have done this on a paper. Let me show you. Yeah. On your screen you can see this. Question number 8. Useful energy will be 65% of the 12 kilojoules. So 65 by 100 into 12 kilojoules, and the answer will be 7.8 kilojoules. So for question number 8, C is the option. Question number 9 is on your screen. Coal is burned as fuel to heat water in a boiler, producing steam. The steam drives a turbine, which is connected to an electric generator. In which order do the major energy transfer takes place? You know, when the coal is burnt, the coal has the chemical potential energy. When it is burnt, the thermal energy is given out. And by the thermal energy, we convert the water into steam. So the water is given the kinetic energy. And the steam runs the turbine, that is also kinetic energy. And the generator, using that kinetic energy, convert it into the electric energy. So the order of the changes of energy can be From chemical energy, heat energy is produced from there, the kinetic energy is produced from there, the electric energy is produced. So for question number 9, B is the option. Question number 9, B is the option. Okay, on your screen, question number 10. A crane moves its load diagonally as shown. By which distance is the weight of the load multiplied to calculate the change in gravitational potential energy of the load? You know the change in the gravitational potential energy is weight multiply the vertical height gained by the load. So if you look at the diagram, here the vertical height gained by the load is this B. The gain or the vertical height gained by the load is B. So multiply it with B. So B is the option. On your screen, we have question number 11. The extension of a spring is measured as weights are added. The graph shows the results. Which point in the spring's limit of proportionality? The point till which the extension load graph or extension weight graph is a straight line. And after that point, the graph starts turning upward. That point up to which the graph is a straight line, that last point is known as the limit of proportionality. The limit of proportionality here is point B. So point B is the limit of proportionality. For question number 11, B is the choice. On your screen, we have question number 12. A metal cone with a circular base is placed on a flat surface. The stability of the cone depends on The stability of this cone depends upon the diameter of its base and the position of its center of mass. Larger the diameter of the base and lower the center of mass, the more it will be stable. So B is the choice for question number 12. B is the choice, the diameter of its base and the position of its center of mass. Question number 13 is on your screen. Objects with different weights are placed on rigid horizontal surface. Which row shows the correct pressure acting on the surface? If you want to calculate the pressure, what you will do, you will divide the weight with the area in contact. So divide 10 with 0.1, get the answer. Divide 20 with 0.2, get the answer. Divide 30 with 0.1, get the answer. Divide 40 with 0.2, get the answer. So this will be the pressure for A, for B, for C, for D. When you will do this, you will observe the only correct answer given in the pressure column is for the C option, which is 300. Because when you divide 30 Newton with 0.1 meter square, the answer is 300 Newton per meter square. So he correctly calculated only in the C option. So C is the option. Question number 13, C is the option. On your screen, we have question number 14. The diagram shows two identical pieces of apparatus. One is filled with water and the other is filled with mercury. Water is less dense than mercury. At which point is the liquid pressure greater? You know, the liquid pressure depends upon two things. The density of the liquid, the formula is rho GH. Density multiply G multiply H, where so the pressure of the liquid depends upon the density of the liquid. It also depends upon the depth of the liquid above the point. So the greatest pressure will be in the vessel which has mercury, and where the depth of the mercury, the vertical depth of the mercury above the point is greatest. So definitely it will be point D because it contains mercury and the depth of the mercury above this point is greatest. So at point D, the pressure will be greatest. So D is the option for question number 14. Question number 15 is on your screen. Which row explains why a liquid has a fixed volume but does not have a fixed shape? The liquid has fixed volume, but it does not have fixed shape. It occupies the shape of the container, but its volume is fixed. So the reason is because the forces between the molecules is large, and they move throughout and the movement of the molecule in liquid is they move throughout the liquid. That is the reason. Simple. For straightforward question number 15A is the option. Okay, on your screen we have to raise the temperature of a 2 kg block of metal by 20 degrees centigrade, energy of 5.2 kilojoules is needed. What is the value of the specific heat capacity of the metal? You know, here the temperature change is taking place. For this, the formula for the heat involved is heat is equal to mc delta theta. Heat is equal to mc delta theta. So the energy is given 5.2 kilojoules multiplied with 1000, so it will be 5200 joules. The change in temperature is 20 degrees centigrade. The mass of the block is 2 kg. And the C is the question, specific heat capacity. I have done this numerical. Let me show you my working. Heat is equal to mc delta theta. 5200 equals to 2 into C into 20, and the C will be equal to 5200 divided by 40, and the answer will be 130 joules per kg per degree centigrade. So this is question number 16. So C is the option. Question number 16. C is the option. 130 joules per kg per degree centigrade. Question number 17 is on your screen. What makes a clinical thermometer suitable for measuring small changes in body temperature? To measure small changes in the body temperature, the thermometer should be very sensitive. To make a thermometer very sensitive, there are 2-3 methods. One method is the capillary, the bore of the capillary should be very narrow. The diameter of the capillary should be small. So for question number 17, B is the option. The bore of the capillary tube is narrow. When the bore of the capillary tube in which the mercury trend moves, if that's very small, the thermometer will become very sensitive. So B is the option. On your screen, we have question number 18. Substances can change from one state to another as shown in the first process, melting, second process, boiling, third process, condensing, fourth process, freezing. His question is let me reduce the size a little bit so you can see all the question. Okay, for substantial change from one state to another, there must be some energy transfer. Which change involves the substances taking in energy, and which changes involve the substances giving out energy? So 1 and 2, melting and boiling, they will be taking in energy. So 1 and 2 will be energy taken. For the process 3 and 4, condensing and freezing, the energy is given out. Energy given out, 3 and 4. So clearly A is the option. For question number 18, A is the option. I hope you have understood it. Question number 19 is on your screen. How does the heat transfer through a vacuum take place? In the vacuum, the heat transfer is taken place by the transfer of infrared radiation. By radiation only. D. So question number 19, D is the option, radiation only. In the vacuum, through radiation, the heat is transferred. Conduction and convection cannot take place in vacuum because they require medium. Okay, we are moving to the next question, and this is question number 20. A ray of light enters a glass block at an angle of incidence I, producing an angle of refraction R in the glass. Several different values of I and R are measured, and a graph is drawn for sine I against sine R. Which graph is correct? You know, when we are talking about question number 20, here you can see there have been given 4 graphs A, B, C, D on the y-axis sine I is represented, on the x-axis sine R is represented in all of the graphs. Sine I is on the y-axis, sine R is the on the x-axis. If you will find the slope of these graphs, that will be equals to sine I by sine R. Whatever is on the y-axis divided by whatever is on the x-axis. Sine I by sine R. And you know, according to Snell's law, sine I by sine R is equals to the refractive index. The refractive index of this glass block will be definitely more than 1. So we are looking for that graph whose slope is more than 1 and it is positive. So when I am looking for a graph whose slope is positive and is more than 1, the B and C will be out of question. So the competition is between A and D. In the D graph, if you look at here on the D graph, for example, approximately this is the graph. Its rise is approximately, suppose it's 0.6 and its run is 1. So when you divide 0.6 with 1, the answer will be something 0.6. So its slope is less than 1. So D is also cancelled out. Now look at graph A. In the graph A, let me increase its size so you can clearly understand what I'm saying. Look at graph A. Look at graph A. Here, its rise is approximately 1 and its run is approximately 0.6. So when you will divide rise by run, it will be 1 divided by 0.6 and it will be more than 1. So A is the option. A is the right graph representing the ratio of sine I to sine R. I hope you have understood. It was a little tricky question. It's not an easy question. Okay, on your screen we have question number 21. A boy stands beside a girl in front of a large plane mirror. They are both the same distance from the mirror as shown. Where does the boy see the girl's image? Okay, so here we have the boy, here we have this girl, and in front of them we have this plane mirror. So if we want to know where the image of the girl can be seen by the boy, very simple, draw a line from the girl straight to the mirror and move it behind the mirror. Okay, check how much is the distance of the girl and how much is the distance. Take the same distance behind the mirror, put a point there, then join the boy with that point and join the girl the point where that line cuts the mirror. It will be here somewhere. So you see the light is reflected from here to the boy, and when I prolonged it behind they intersected here. So probably the boy will be able to see the image of this girl at point A. A little bit tricky. If you have the hard copy of the paper in front of you, please, as I have instructed, draw those lines and you will be able to understand why the boy will see the girl at position A. So A is the option. Okay, question number 22 is on your screen. How do the speed and the wavelength of red light in air compares with the speed and the wavelength of the violet light in the air? You remember that code, Roy G. Biv. Roy G. Biv. ROYGBIV. This is the order of the colors. And the top color, red, Roy G. Biv. Red has the longest wavelength, and the violet has the second smallest. Its wavelength is smaller as compared to red. The red and the violet both will have the same speed in the air. The red will have the longer wavelength or greater wavelength. So the speed will be the same, but the wavelength of the red will be greater. So C is the choice for question number 22. Okay, on your screen, we have question number 23. The diagram shows the main sections of the electromagnetic spectrum In order of decreasing frequency, some of the sections, in order of increasing frequency, some of the sections are labeled. The section R has a frequency just below that of light. Which application uses the section R? Okay, you remember the code for the electromagnetic spectrum? We say Ronald McDonald is very ugly except Gary. Ronald McDonald is very ugly except Gary. So Ronald McDonald is stands for, I stands for infrared. So R is infrared. And you know, famous use of infrared is in the television and remote controllers. So for question number 23, D is the choice. Okay, on your screen, we have a student uses a spring to demonstrate waves. He moves the spring with his hand. Which diagram demonstrates the type of waves produced by a source of sound? You know, the source of sound produces longitudinal waves. And in the longitudinal waves, we have compressions and we have rarefactions. In the compressions, the particles of the medium, they are very close to each other. The pressure is high. And in the rarefaction, the particles of the medium are away from each other. The pressure is low. In the diagram B, if you look at the diagram B, the some places the coils of the spring are close to each other, and in some places the coils of the spring are away from each other. So the diagram B is showing the compressions and rarefactions, compressions and rarefactions. So B is the choice for question number 24. Okay, on your screen, question number 25, waveforms are shown on a cathode ray oscilloscope for a flute and for a guitar, each playing the same note. The oscilloscope settings are the same for both waveforms. What is the difference between the two sounds? This is a famous question. And you know, they have the same amplitude, they have the same frequency. The only difference is in the basic shape of the waves, and we call it quality, timbre. So question number 25, C is the option. Question number 25, C is the option. Okay, here the diagram shows an alarming system. So battery P, and it has a iron core and a solenoid on it. So when current will flow through this, it will be a electromagnet. Here in the second circuit, we have an iron armature, and when this is electromagnet, this iron armature will remain up. But if you disconnect this battery P, if you switch off circuit number 1, this iron core will be no more electromagnet. When it will be no more electromagnet, this iron armature, which was lifted upward due to this electromagnet, this iron armature, under the influence of its weight, will drop down. When it will drop down, this second circuit will be completed. It will touch this thing and it will be completed, and this bell will start ringing. Let us read the question. The question is, what happens when battery P is disconnected? So when battery P is disconnected, the iron armature will fall and the bell will ring. So question number 26, A is the option. Okay, on your screen, we have next question. The resistance of a cylinder wire P is 80 ohm. A second wire Q is made from the same material. The cross-sectional area of the Q is 4 times that of P. The length of Q is twice the length of P. What is the resistance of the Q? Suppose the length of P is L and the cross-sectional area of the P is A. And you know, the length of the wire Q is 2L and the cross-sectional area of the Q is 4A. This was given in the question. Because both the wires are made of the same material, so both of them will have the same resistivity. And by making their resistivity same, and then by putting the formulas of the resistivity, we can tell what will be the resistance of Q. Let me show you my working. I have done this on a paper. Let me show you that. Okay. Oh, it looks very dim, but I hope you can see that. Okay, so let me read it for you. Because both are made of the same material, so the resistivity of the P and the resistivity of the Q will be same. The formula for the resistivity will is R multiply area divided by length. So R1 A1 by L1 is equals to R2 A2 by L2. R1 is 80, area is A, and the length is L. R2 is question, area 2 is 4A, and the length 2 is 2L. So A and A will be cancelled, L and L will be cancelled. This 2 will go on the other side, multiply with 80, and the 4 will go on the other side and it will divide with 80. And the R2 value will be 40 ohm. So for question number 27, B is the option. I hope you have understood it. It's a numerical and it involves the formula of resistivity. So the answer is B. Question number 27. The answer is B. Okay, on your on your screen, the diagram shows a potential divider system of two resistors connected to a 6-volt power supply. What is the reading on the voltmeter? You remember, this is a typical circuit diagram of a potential divider. And here, this 2000 ohm, it is R1. This 10,000 ohm is R2. And we want the V out on R2. If you want to find out the V out on R2, you can apply the formula V out is equals to R2 divided by R1 plus R2, and the whole thing is multiplied with the voltage of the battery. I have done this on a paper. Let me show you my working. On your screen, you can see V out is equals to R2 divided by R1 plus R2 multiply voltage of the battery equals to R2 is 10,000 divided by 10,000 plus 2,000 multiply voltage of the battery is 6. So it will be 10,000 divided by 12,000 multiply 6. And the answer will be 5 volt. So D is the option. This was a question related with the potential divider, and you should remember that the V out on R2 can be found by the formula R2 divided by total resistance R1 plus R2 multiply voltage of the battery. I hope you have understood it. So for this 28 question, D was the option. Okay, question number 29 is on your screen. In the circuit shown, the alarm bell will only start ringing sometime after the switch is closed. What causes the time delay? You know, here, this is the electric circuit symbol for the capacitor. So what happens? First, this capacitor will charge, and then this bell will ring. So for time delay in the circuits, we use capacitors. So the time delay happened because the capacitor was charging. So question number 29, it's electronics. Question number 29, the capacitor charging. A is the option. For question number 29, A is the option. Okay, on question, another question is on your screen. Question number 30, an appliance used a 240 volt supply is most likely to burn out its fuse. So their question is, which appliance will burn out? So these are the ratings of the fuses which you have installed. So the voltage is 240, the power is 100. So what you will do, you know, the power is equals to IV, power equals to IV, and I is equals to power divided by voltage. So for every appliance, calculate the value of the current it will take. Power divided by voltage. For the A, 100 watt divided by 240 volt. For B, 1000 watt divided by 240 volt. For C, 2000 watt divided by 240 volt. For D, 3000 watt divided by 240 volt. For A, B, C, D, calculate what is the current that device or that appliance is taking, and then check if that current is less than or more than the fuse rating. If the current you calculated is more than the fuse you have tied there, that appliance, its fuse will burn out. I have done this calculation. Let me show you. Okay, on your screen is the today I did the work with the blue ball point and it's not clear in the photos. So I calculated IA, which was 100 divided by 240. The answer is 0.42 ampere, and I calculated IB, that is 100 divided by 240. The answer is 4.2 ampere. I calculated IC, that is 2000 divided by 240, and the answer is 8.3 ampere. And I calculated ID, that is 3000 divided by 240, and the answer is 12.5 ampere. You see this C, the current the appliance will take is 8.3 ampere, but the fuse which you put there is only 3 ampere. So it means that this fuse will blow. So for 30C is the option. Okay. On your screen, we have question number 31. The current in a filament lamp is 0.25 ampere. When working normally, the lamp is connected to a plug and the main AC supply. When the lamp is switched on, it does not lit. What is the possible cause for this? The possible cause might be that you have not connected the live wire, and that can be the reason. So D is the option. The live wire in the plug is not connected. Okay, on your screen we have, let me reduce the size. Yeah. Question number 32 is on your screen. A lamp designed to work at 1.5 volt is connected to a cell of electromotive force 1.5 volt. The lamp lights at normal brightness. The lamp is now connected to four similar cells, each of EMF 1.5 volt, arranged in parallel. What is the effect of connecting the extra cells in this way? When we connect the cells in parallel, their EMF do not add up. Their EMF remains as that of an individual cell, but they last longer. So their life becomes longer. So the answer is the lamp produces light for a longer time. For question number 32, C is the option. The lamp produce light for a longer time. Okay, on your screen we have question number. On your screen we have question number 33. Two metal spheres X and Y are on insulating bases. Both spheres are negatively charged. X insulating, so see, this is X as a metallic conductor, and metal sphere, sorry, it's a metal sphere. It's on an insulating stand. It has negative charge. The Y is also a metallic sphere on an insulating base, and it also has negative charge. Sphere X is moved towards sphere Y until they almost touch. They did not touch, but they almost touch. Which diagram shows the final pattern of charging? You see, these negatives should be, when you try to bring them close, they should be repelling each other. So if one negative goes to the left, the other negative should go to the right on the other sphere. So it looks to me C looks better option. The movement of the charges should be like the one shown in the C part. So for question number 33, C is the best uh, diagram. C is the option. Okay. Now, question number 34 is on your screen. The diagram shows three electrical devices, X, Y, and Z, and which device provide an alternating current AC output. You know, this is a generator. It has two slip rings. This is a generator, so it is provided alternating output. This is not a generator. Here, this is the split ring commutator. It's a motor. So it do not produce alternating current. This is dynamo. This Z is dynamo. This produces alternating current. So X and Z, they both give output AC current. They both are generators. So X and Z. So for question number 34, D is the option. For question number 34, D is the option. Okay, on your screen we have question number 35. One component of a simple DC motor is a split ring commutator. Which metal is used to make the commutator and why is this metal chosen? We use for the split ring commutator we use uh, copper, and because it's a very good conductor of electricity. So for question number 35, A is the option. For question number 35, A is the option. Okay, let me reduce the size so you can see this question, the whole question. Two parallel wires carry currents in the same direction. Which diagram shows the magnetic field around each wire and the direction of the force on each wire? You know, if you have two parallel conductors like this, and the direction of the current in them is same, then both the conductors will attract each other. So C and D, they are out of question. They are wrong. Just neglect that. Now, the direction of the magnetic field around a straight conductor can be found by the right hand grip rule. For example, in take your right hand, I'm saying the right hand, and for example, in A, hold the right conductor in your hand, the current is going down. The curls of my finger, the curls of the right hand are telling me that the direction of the magnetic should be clockwise. And if I hold the left wire, the current is going downward. With the I'm holding it with my right hand, the current is going downward. My thumb is in the direction of the current. The curls of the right hand are telling me that the direction of the magnetic field around this conductor should be clockwise. So A is the right option. A is the right option. In the B, you know, the B is wrong. Why B is the wrong? Because the right wire here, the magnetic field around the right wire is anti-clockwise. So that's wrong. So A is the choice for question number 36. Okay, on your screen we have question number. Okay, let me reduce the size. Okay. On your screen, we have question number 37. A small coil is connected to a galvanometer G as shown. When a magnet is allowed to fall towards the coil, the galvanometer pointer gives a momentary deflection to the right of the zero position. The magnet moves through the coil. What happens to the galvanometer pointer as the magnet falls away from the coil? So when the magnet will pass through this coil and then it will move away from the coil, the in the first case, you know, the pointer of the galvanometer deflected to the right. Now, when the magnet will pass through and then it will fall, the pointer of the galvanometer should be deflected in the opposite direction. So first it was deflected to the right, now it should deflect to the left. And this deflection should be for a moment. So for question number 37, B is the option. It gives a momentary deflection to the left. Okay, on your screen we have question number 38. The isotope barium 140 has a half-life of 13 days. A sample of this isotope is kept for 13 days. Which quantity halves during this time? You know, the the parent nucleus, the parent nuclei which was present, they will become half. So the number of atoms of barium 140 in the sample they will have. So A is the option for question number 38. A is the option. Okay. Question number 39 is on your screen. In a laboratory experiment, particles from a radioactive source are deviated by a magnetic field and reach a detector. The particles are deviated and reach the which particles are deviated and reached by the detector. Okay, so here we are talking about a magnetic field and charged particles, and they are deflected. I can apply the left hand rule. I can apply the left hand rule. Okay, so your left hand, this is my left hand, please. Your left hand. Stretch your fingers, thumb, index finger, the middle finger, thumb, index finger, the middle finger, in such a way that they are perpendicular to each other. They are mutually perpendicular to each other, like this. Then, this is called FMC. FMC. Force, magnetic field, current. Force, magnetic field, current. Thumb is in the direction of the force. This index finger is in the direction of the magnetic field. This middle finger is in the direction of the current or charges. Okay. So the magnetic field was into the page. The charges were going downward. My thumb points towards the right. But the charge particles deflected to the left. My thumb is pointing to the right, but the charge particles are deflected to the left. This means that these charge particles are negatively charged because this left hand rule, is for the positive charges. But the charges in this example, they deflected opposite to what my thumb is pointing. So this shows that the charge particles involved here, they are negatively charged. It means that they are beta particles. So for question number 39, D is the option, beta particles. I hope you have understood it. Okay, on your screen we have question number 40. One isotope of carbon is carbon 614. How many neutrons and protons does each atom of this isotope contains? So number of neutrons, 14 minus 6, it will be 8, and number of protons is 6. So I think the C is the option. Question number 40, C is the option. It was a very simple question. So that's it, G. This was question number 40. Okay. So this was October, November 2011 to 1-2 paper. It was an MCQ paper. The course is Physics 5054. I have done my best to explain these concepts. I hope that I am to some help to you. Keep studying hard and keep practicing, and your answering skills and your MCQ skills will improve. Thank you very much, everybody. Have a good day.